Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
How are you? Some okay? Okay. Now, before we start, I have one or two things I need to talk about. Number one, group. Okay, as per the WhatsApp, I think everybody has already a group. Now, in case anybody who doesn't have a group, please put your name in WhatsApp so that we can arrange. Okay. So as of yesterday, I think we already have everybody in the group. Now, I don't have to repeat this a few times. The group must be of the same section. The reason is simple, because your name, okay, the class list is based on section. So it's easier, it's easier for me to record the marks if you are in the same group. If you are different group, then it will be very, very difficult. Okay, so simple reason is just that. Okay, I think everybody should be clear on that one. I said that already, and some people still ask me question on that one. So I hope people already get the idea. Now the classroom I will do it by next week. Because classroom, I don't use classroom that much. We use classroom only for doing the tests, homework, like that. Okay, so I don't use that much of classroom. So what we'll do today, we will continue from where we left on Wednesday last week. We're going to talk a little bit more about the slope and the intercept, and then you are going to do it the other way around. If you are given a few information, some information about the function, how can we get the equation of the function? So that is what we're going to do. And then we are going to look at application of linear function. So hopefully we can cover most of what I intend to do. Now, before we start, any question from the last class? Any question from the homework question? Anything? Okay. All right. I hope everybody did try the question. And if you have anything, you can always come up with the
mencintai ko.
Ya, apa dia? You have a question or you don't have a question?
Yeah.
Okay, let us continue. All right. Now we stopped last class. We were talking about the intercept. Okay. So we go back to the intercept, and now we'll talk about the slope a little bit. Now, intercept is the value of that variable when the other variable is 0. So if you have the Y-intercept, all right, Y-intercept is the B. So you have the function. We have the function y equal to mx plus b. Now we know b is the y-intercept. All right. Now when b-intercept, y-intercept, what do we know about the y-intercept? Is the value of y. Okay, the value of y at or when x equal to 0. And that value of y, okay, the value of y at or when y equal to 0 is what? Is b. So b is the value of y. So if you put the other way around, means b is the value of y, okay? The value of y when x equal to 0. All right, so that is the b. B is the y-intercept. Now, what is the x-intercept? X-intercept is not so straightforward. because it's where the line cuts the x-axis, and it is not straight coming from the equation. Okay, so if you look at the graph again here, you have here, this is the x-intercept where it cuts the x-axis. The y-intercept given by the function, okay, it's b. But this one, you have to find. Okay, so how to find? To find is not difficult. So we know the x-intercept is the value of x when y equal to 0. So by using that concept, we can find the x-intercept. So let me get that. So x-intercept is the value of y, okay? The value of y, no, I'm sorry, the value of x at or when y is equal to 0. So we are given the function, okay, y equal to mx plus b. So when y is equal to 0, we substitute, okay? Substitute into the function, into y, what do we get? We get 0 equal to mx plus b. Now, what is x? What is x? Look at the thing that I have here. Okay, what is the value of x? Okay, so for the x. Okay, what do you get? Anybody get the value of x? Now, do you hear me or you don't? Ni saya cakap semua diam ni.
Dengar.
Dengar. Okay, what is the value of x? I give you 2 minutes. Okay, work it out. Make the transformation.
Negative b over m.
Good. X is negative b over m. So if you work this out, you bring the b to the side, become negative. I hope everybody know this one is already known. Okay, negative b over m. So that is the x-intercept. So the value of x when y is equal to 0 is, okay, I write down here because you have to find, is what? Is negative b over m. So negative b over m, okay, just like what we were doing for the x, for the y-intercept. So negative b over m is the value. That's the x-intercept, right? The value of x at or when y equal to 0. So that is the x-intercept. Okay. Now this is important because when we do application, we have to get we have to be clear of the concept. Then we can relate. Okay. Then we can relate to the application, and then we can describe it or we can interpret the meaning of those intercepts. Okay, any question? For example, all right, example, if I have y equal to negative 3x plus 21. Okay, now we have already the function given, right? What is the y-intercept? Number 1, y-intercept. What is the y-intercept?
21.
21. Y-intercept is 21. That means an x equals to 0. We know that y is equal to 21. Okay. Now I skip the working. All right. So you go home, do the work. Okay. Do the substitution because I think I may need to save some time. Okay. We have to show the substitution. So y equal to 21 is the y-intercept. So when the x equal to 0, okay, when x equal to 0, what is y? Y is equal to what? Equal to 21. Or the value of y is 21. Okay, when x equal to 0, the value of y is 21. Okay, all right. Now we go to the second intercept, that is the x-intercept. Now, how do we get the x-intercept? Simply put y equal to 0 into the equation. Okay, and then you get the x-intercept. Okay, do it now. Get the x-intercept. Putting the y equal to 0 into the equation, get the x-intercept.
7.
7.
Huh?
7.
11. Good, good. Okay, everybody got 11. Okay, so that is the
7,
value
sir.
of
Sir.
x
7.
when y is equal to 0. So you look at the concept. Okay, x-intercept means we substitute y equal to 0 into the y, okay, into the equation. So what do you get? You get 0 equal to negative 3x plus 21. So you will get, okay, x, or if I work this a little bit, okay, because I want to show how we got it, equal to 21, x equal to 21 over 3 equal 7. So that's how you got 7. So if you look at this thing here, that will come from the one that we were doing, negative b over m. Okay, but you don't have to remember this lah. You know, actually, that was for the general form. But more importantly is how to able to find, okay, from the understanding. It is the value of x when y equal to 0. So therefore, what you say is that the value of x, all right, when y is 0 is what? Is 7. So that is the x-intercept. All right? Okay, any question about that? Okay, good. Now, the next thing to do is we want to look at the slope, all right? Now, we know the slope is a measure of steepness. Okay, the slope can be positive. We were talking about the slope. I haven't said positive or negative, but the slope, we can look at the possibilities of the slope. I go back to the graph. Where was the graph? Okay, the slope, normally we measure from, or we describe the slope from left to right. Okay, so the slope can go upward. Okay, can go upward, the black lines. And the slope can go downward, the red line. All right, now that is the slope. Now, if you look at the steepness, okay, if you look at the steepness, you can see here the black lines, okay, the hill, like the hill, you know, the line going upward. We already know that the steeper lines are the one that is more difficult to climb, just like a hill, you know. So if you see here, this line number 1 is steeper than the line number 2. Okay, this line number 1 is steeper. Number 2 is more flat. Okay, okay, that's number 1. Number 2, if you look at the downward going line, all right, we can also describe the steepness of the line by, of course, you can go now. Okay, for this one, you can reverse your direction. You can describe it by going from the right to the left. All right. But I don't have to. I just going from the left to the right. So if you go from the left to the right, we measure steepness. Okay. So in this case here, the one that is what? Which one is more steeper? Line number 1, line number 2, or line number 3? Which one is steeper? Steeper here means, I think, yeah, that's a good idea. One steeper. I think maybe you can go from right to left. No, you go from right to the left. That means, again, the concept is which one is more difficult to climb. All right. Doesn't matter where the direction of the hill is, as long as it's more difficult to climb, that is steeper. All right. So line number 1 is steeper than number 3. So I think you can go that way. You know, you look at from the right to the left, or if you're going from left to the right, which line is more difficult to go down? Okay, you can do also that. Which line or which hill is more difficult to go down? So the one that is number 1 is more difficult to go down because it's very steep. So number 1 is steeper than number 3. So steepness, you know, is just a measure of, or the slope, just a measure of the steepness of the line. Okay, all right. Now let's go into more detail of the concept of the slope. The slope is the value of m, okay, the value of m, and that is given by what? If you look at the slope, okay, slope is equal to the following. The slope m, all right, that is equal to the, you know, is a measure of the steepness of the line. That is equal to, given by the following relation or the following formula, delta y over delta x. Okay, and that is equal to y2 minus y1 divided by x2 minus x1. Given, okay, given x1, y1 and x2, y2 on the line. That means 2 points, okay, given 2 points on the function. So let us elaborate a little bit about the slope. Okay, this is the definition of the slope. All right, it's a measure of steepness. And how you get the slope is by that formula. Okay, it's a measure of steepness, okay, of the line. Now, given the 2 points, okay, given the 2 points on the function, the slope is equal to delta y over delta x. Now, first one, what is delta? Okay, delta here means the change. Okay, it's a change. So delta y means what? Means the change in y. Okay, change in y. Delta x is, by the same token, is the change in x. So it's the ratio of changes. It's the ratio of the change in y divided by the change in x. So if you look at the value of the changes, you will be doing it, or how do we get it, is by taking the difference. So if you want to find the change, that means you take the difference. Difference between what? The difference between the new value minus the old value. So that's how you got the change. It's like, how do you get the change of your GPA? Okay, the change of your CGPA or the change of your GPA from this semester next semester. How do you get the change? You will get, you take the difference. Okay, your GPA this semester subtract your GPA last semester. So that is the change of your GPA. Okay, okay. Now here the slope is not just the change. Okay, it's the change of one variable divided by the change of another variable. So then we got delta y over delta x, and that is equal to y2 minus y1 divided by x2 minus x1. New value of y minus old value of y divided by the new value of x divided by, divided by, minus the old value of x. So that is the measurement of the slope. So let us look at an example. Now I give you a function, okay, yx. Let's say I have a line something like this. Okay, so here you got the y, and then I want to find the slope of the function. Okay, now the slope of the function from this formula is delta y over delta x. Okay, and then you need, or you are given here 2 points, y2, y1, x2, x1. So let us consider 2 points. All right, so let us say that is y1, x1. Oh, no, I'm sorry, x1, y1. And then there is another point here, x2, y2. All right, so you have 2 points given. All right, so given the 2 points, x1, y1, say, equal to what? Equal to, I think that the equal, we do it later afterwards. Given x1, y1, and x2, y2, then you can find the slope. Now, sometimes you label, okay? You label the points. We suppose that x1, y1, you can call it A, and then the point x2, y2, you call it B. So you can call it this point A, that point B. Okay, you can also do that, but it's just an option. Okay, so now the slope is equal to the change in y. Now, as you know, the change in y is y2 minus y1. Okay, you know the change in y is equal to what? Y2 minus y1. The new value minus the old value. So if you look at the graph, what is the change in y? Change in y is simply the difference between y2 minus y1. So that is the change in y. Okay, now what is the change in x? The change in x is the difference between the new value of x and the old value of x. So that's it. That is the change in x. Okay, so you bring that to the line, you will see here, that's the change in y. That is the change in x. So the ratio, okay, the ratio of the change would be the value of the steepness of the line. That one. Okay, so you got that. So that is how you measure the degree or the steepness of the line. Taking the ratio of the change in y divided by the ratio in the change in x, then you get the slope. Let's give you the idea of how steep the line is. All right? Okay. So let's relate to some values. So let's suppose x1, y1 is equal to, say, 2, 4. And the value of the x here, say 10. Here, probably 6. So the slope, okay, the slope will give you, or is given by the ratio of the changes. So now find the slope. So again here, you simply substitute. All right, so you do it by substitution. Okay, now I want you to substitute the values to get the slope. Okay, you got it? So the slope here, all right, the slope m is equal to delta y over delta x equal to y2 minus y1 divided by x2 minus x1. Now, given, okay, given x1, y1 equal to what? Equal to 2 and 4. 4 and 2, is that right? Berapa tadi? Saya pun dah tak ingat.
2, 4.
2, 4.
2, 4.
2 and 4. 2, 4. And then x2, y2 equal to 6 and 10.
No, sir. 10, 6. Sir.
Huh?
10 and 6.
10 and 6. Thank you. So it is 10 and 6. So what we do, we substitute. So by substitution, okay, you will get m equal to what? M equal to y2 minus y1, which is 6 minus 4, divided by 10 minus 2. What do I get? I get 2 over 8. Is that right?
Yes.
2 over 8.
Yes.
That is equal to 1 over 4.
4.
Now 1 over 4, you can convert to decimal point. It's becoming 0.25. Is that right? Okay, 0.25. Okay, okay, now I want you to find another slope. Okay, this one, fine. Given x1, okay, given x1, y1 equal to 2 and, banyak sangat 2 ni. 3 and 5. And then x2, y2 equal to 6 and 20. Okay, get me the slope.
Five, sir.
M equal to what?
5, sir.
5. Okay, good. Everybody got 5. If you don't get 5, go home, work it out. Okay. So apply the formula. You will see here. Now, if you look at the value is 0.25. The value here is 5. Now go back to the graph. Okay. If you go back to the graph, this one is the one that you found for the first line. Okay. Now let me get you the second line. So you got here 3, 5, and 6, 20. So 3, 5 will be somewhere here. Okay, 3, 5 will be somewhere there. And then I have here 620 will be somewhere here. All right. Now, if you look at the line, I connect the 2 points. It will be something like that. Okay. So that is number 1. That's number 2. Now the slope here is equal to 5. The slope here is equal to 0.25. Okay, now what can you say about the value of the slope? You know already a slope is a measure of steepness, okay? Okay, now what can you relate? How can you relate the value of the slope to the steepness of the line? Value is 0.25, the other one is 5. Which one is steeper?
5.
5. No?
5.
So the higher the value of m, all right, the higher the value of m, actually this one, okay, is only relating to the m bigger or equal to 0. So if m bigger to 0, the higher m, okay, that give you the idea. You don't have to draw the line. Be steeper slope, okay, or steeper line. So you know the higher the value of the m would be what? The steeper line. Okay. All right. Now let's do another computation. Okay, I'll give you another one. Example number 2. Given x1, y1 equal to Okay, equal to 2 and 2 lagi. 5 and 1. Okay, 5 and 1. 5, 5, 1. 5, 1. And then x2, y2. x2, y2 equal to negative 2, 21. Okay, fine. Negative 2, 21. So if I can draw the line, it would be like this. X, Y, 5, 1 be somewhere, say 5, 10, 15, 5, 10. Okay, negative 5, negative 5. 5, 1 be somewhere here. Negative 2, 21 will be somewhere there. Today. Okay, find the line, find the slope. Call this number 1. Of course, there is 1. Okay, back. Anybody got it?
Negative 20 over 7.
Okay, m equal to negative
20 over 7.
over 7. Okay, convert to decimal point, please.
Negative 2.86.
2.86. 2.86. Yeah. Okay, good. So here you have a negative slope. Okay. What I was talking about just now, positive slope. Okay. So now we are going to get some negative slope. Now I'll give you another example. Let's say example number 3. You got x1, y1 equal to, I give you the same point, 5, 1, senang sikit nak refer. 5, 1, the other point, x2, y2 equal to, 5, 1 sini, equal to, tunggu sekejap. Ini berapa ni tadi? 21. 21 tu, sampai situ. Okay, negative 2. Negative 1, negative 15. Okay, number here, 15. Okay, 15, negative 2. Negative 3 lah. Okay, find the slope. So the point here is 5, 1 is that point. And then I have 15, negative 3 will be somewhere here. So what you got would be this line here. So call it number 2. Now, what is the slope?
Negative 0.3.
Okay, here everybody got negative 0.3. Okay, if you have a new value, anybody get different value? I just want to reconfirm that this is the correct one. Okay, so everybody should get this. If you don't, go home, prepare. Okay, rework it. So now the value here is negative. Okay, the value of the slope is negative. So that means you have the change over the change of y divided by the change in x is negative. Now, when it is negative, what does it mean? It means that, okay, by the interpretation of, or by the description of the value, okay, it's simply what? It's simply, again, here, the slope. So we say what? What do we say? We say that, we haven't talked about the interpretation of the slope. Okay, just focus on the steepness, okay, and then we look at the how you describe it. Okay, in terms of the steepness, you have here the slope line number 2, negative 0.3. The slope of the line number 1 is negative 8.6, 2.86. Now, which one has a higher value of the slope? The line number 2 or the line number 1?
Number 1.
Number 1.
Okay. When you look at the higher value of the slope, okay, here, the higher value of the slope, there are two things here. Number 1, if you look at negative value, okay, for every x less than 0. Now, which one is higher? M equal to negative 0.3 or M equal to negative 2.86. Which one is higher in value mathematically? It's not about the slope.
0.3 negative
0.3.
You see here as a mathematical value, 0.3 is bigger than negative 2.86. Okay, so that one we should know, number 1. Now, number 2, when you look at the steepness of the line, okay, if you look at the steepness of the line, we go back to the graph here, we will know that line number 1 is steeper than line number 2. Is that right? Line number 1 is steeper than, I should write steeper than number 2. Okay, but in terms of the value of the slope, the value of the slope M, okay, the value of slope of line number 2 actually is larger than the value of the slope line number 1. Okay, so what we conclude here is that what? To measure steepness, you for negative slope, okay, you don't look at the value of the slope. What do you look at? We look at the absolute value. All right. So for M bigger less than 0, you look at the absolute value. That means we disregard the negative sign. Okay, disregard the negative sign. Because if you consider negative sign, of course, negative 0.3, the nearer to the 0, it means higher the value. All right. But when you relate, when we relate to the steepness of the line, the slope, we look at the absolute value. Okay. So in other words, the absolute value of negative 0.3 would be 0.3. And then the absolute value of the negative 2.86 will be just 2.86. So therefore, this line here, okay, this line here is steeper than that line. So when the slope is negative, we don't look at the value. We look at the absolute value. All right, absolute value of the slope. That means disregard the negative sign. Because when you look at the steepness of the line, you just want to see how steep the line is. So for M less than 0, that is the story. Okay, any question? Now I'm sorry, no, M bigger than 0, M less than 0, right? For M bigger or equal to 0, no problem. Okay, that one is very easy. M less than 0, okay, you have to understand that. All right, because the steepness is simply the value of the slope. Okay. All right. Any question?
Yes, tapi itu punya
Good. Now we want to look at the interpretation of the slope.
problem
See?
sikit
So
kot.
you got y equal
Yeah,
to delta
buat
y
dekat
over,
line.
I'm sorry,
Ini
M
dah
is delta y over
patut.
delta x. Yeah. What is it? Munira, you have something to say? Anything? Any question? Okay. So here delta y over delta x, that means the change in y divided by the change in x. Okay. Now, you can see here, the m can be positive, the m can be negative. All right. So if I talk about m positive, okay. Now, if m is positive, what about the change in x, change in y, so that you get m positive? What should, okay, the change in the y or the change in x? That means, would that be a positive change or negative change in x and y when you have the slope positive? So when the slope is bigger than 0, here, you got the change in y over the change in x, all right? So when the slope is positive, that means the change in y, was if the change in y is positive, what about the change in, I'm sorry, if the change in x is positive, what about the change in y? Must also be positive, all right? But the change in x and the change in y is not necessarily positive. It can be negative. So if the change in x is negative, what about the change in y for the slope to be positive?
Negative.
Should be negative, huh? Okay. So for the slope to be positive, you will see here the change in y and the change in x will be same direction. Either both are positive, both negative. Okay. If the change in x is negative, that means the change in y will be also negative. If the change in if the change in x is positive, the change in y will also be positive. Okay, all right. Now, when the slope is negative, or for the slope to be negative, then what about the change in y and over the change in x? I draw another one here. If the change in x is positive, for the m to be negative, what about the change in y?
Negative.
Should be negative. Okay. Now, if the change in x is negative, what about the change in y?
Positive.
Positive. So here, different direction. Opposite. I'm sorry, it should be opposite. Opposite direction. Okay. The change is in opposite direction. If one value, the change is positive, the other value, the change would be negative. Okay. All right. Now, when you have a positive change, okay, the change here can be positive, can be negative. The change can be positive, can be negative. If you have a positive change, so here we go a little bit forward, positive change. Okay, we call it increase, or simply arrow up. If it is a negative change, what do you call it? We call it decrease. Okay, decrease. Cuma ni hijau decrease. Arrow down. Okay, so that's how you relate. Okay, the value of the slope to the changes. Right, the change can be positive, can be negative. Okay, number 3. How do you describe the change? Okay, how do you describe the change? Okay, now for the straight line, for straight line, linear function, the m is constant. That means the line is the same everywhere. So if you take any 2 points, the slope will be the same. Okay, slope is constant for the same straight line. Okay, so if you have that, then we can say the following. We can say M, okay, is the change of Y, okay, per unit change in X. So the value of the M, okay, is the change in the Y for a unit change in X. Correct? For a unit change in X. So that is the M. Okay? So you describe the slope, which is M. It is what? It is the change in Y per unit change in X. So that is the slope. Okay? All right. So now we go into a little bit more specific in terms of negative or positive change. If, okay, the change in the X is negative, positive, a unit increase. Okay, you can say here the change in the X is increase. So the change in the Y can be increased, can be what? Can be decreased. Okay, depending on the value of the M. Okay, so I'll give you an example. Let's say we go back to our example here. Tadi mula-mula M tadi berapa kita dapat? Okay, mula-mula M you got was, okay, we look at the positive value dulu. Positive slope, the first slope we got was equal to berapa? 7. Ini intercept. Mana slope dia?
0.25.
0.1
over 4.
yeah.
0.25.
Okay, the first one you got is 0.25. So now, how do you describe the change or the slope, which is 0.25, in terms of the ratio of the change? So based on what we have discussed, okay, this is how we're going to do it. Okay, now, example, M is equal to 0.25. So M is the change in Y, okay? Or you can say Y, M is the change in Y per unit change in X. Or you can say M is the, or you put the other way around, the change. Okay, I write down here. Or you just rearrange the sentence or rephrase the sentence. The change in Y for a unit change in X is M. Okay, either you can write, you can describe it in terms of the first sentence or the second sentence. Okay, example here, you have M equal to 0.25. Now 0.25 is actually 0.25 over 1. So you see here per unit change in X. Now I want to relate to delta Y over delta X. So if, okay, if I say that X, the change in X is positive, that means increase. And then the change in Y will also be positive because the value is positive. Okay, the value of X, the value of the slope is M, positive. That means X increase, Y will also increase. And that increase of Y is given by the slope. So how do you describe the slope? I describe the slope the following. 0.25 is, okay, you know it's the change. Okay, it's the change of Y per unit change in X. Okay, 0.25 is the change in Y per unit change in X. or the change in y for a unit change in x is what? Is 0.25, the slope. Now, we go more specific. If I say increase or decrease, how do you describe it? So now let's say x increased by 1 unit. Instead of just saying change, we use increase or decrease. Suppose x increased by 1 unit. All right. So how do you describe the slope? Or what is the change in y? So the change in y will also be what? Will also be positive. So increase in y. So we say what? We say m, okay, 0.25 is the increase in y per unit increase in x. Or the increase in y for a unit increase in x is 0.25. So instead of just saying change, okay, we are more specific. We are looking at increase or decrease. Okay, right. I want you to try to write it down. So we do the following. The increase in y for a unit increase, okay, because I row up means increase, unit increase in x is what? Is 0.25. Because the slope is positive, okay, slope is positive, meaning if x increases, y decreases. Okay, any question about that? Okay, now I go back to the graph. Now let's say if the x, okay, if the x is negative, the change in x is negative, that means x decreases by 1 unit. Now what about y? Slope is 0.25. If x decreases, what about y?
Decrease too.
Y should decrease also. So y should have a negative sign, decreases. Because to have a positive slope, they both move same direction. So we can also say that instead of saying m is the increase of y per unit increase in x, we can also say in terms of decreases. So m is the decrease in y per unit decrease in x. So it can go either way. All right. So we can also put here decreases. So go back to the example. So in terms of decrease, you can say that the decrease in y for a unit decrease in x is how much? Is 0.25. Okay, so either you say increase, decrease, decrease. So this one is both is relevant, all right? Because when you look at the changes, you don't necessarily look at increase. Sometimes we look at decrease. Okay, having said that, normally, this is the situation. We, in normal situation, we would say for a unit increase in x, then you look at the change in that y. All right. Okay, good. Any question? Okay, now look at the second example. Example number 2. M tadi berapa? Lupa. Saya nak flip jauh kan? The second example, positive slope. Tadi berapa M? Berapa M tadi? 5 eh? 5 eh?
5.
Okay, slope is M equal to 5. Now, when you see 5, it's equal to 5 over 1. So that is delta y over delta x. So here again, you are looking about what? When you look at the ratio, it's 1 unit change in x, okay? And then the change in the y would be equal to m. All right. Now we go more specific. We are looking at increase or decrease. So by using increase or decrease, I want you to describe the slope 5. Anybody?
Yeah.
Okay, yeah. Somebody try. Cepat. Tadi. Siapa tadi tu? Okay, Muhammad. Give me in terms of the increase. Okay, anybody? Oi, ni ramai lagi belum letak gambar ni. Okay, put your picture so that I can have an idea of my students. Otherwise, I do not know, how you look like. So put your picture. Okay? Oh, ramai lagi tak letak picture ni. Alright, now, apa dia? How do you get the value? How do you describe it? Cepatlah, anybody. Okay,
The increase
okay, go ahead.
the increase in y for a unit, increase in x is 5.
You got it up the other way around. You get upside down. It's not that way. You try again. It's the one that changed. Okay, per unit is x. So for 1 unit increase in x, then the slope is the change in y. What you were saying, you got it the other way around. You terbalik. Betul tak?
Okay.
Okay. Okay, repair balik yang tadi tu.
The increase in
Betul tu, increase in y.
the increase in y for a unit increase in x is 5.
Okay. So that's how you do it. You see here, it's the unit increase in x. That is the one that is in the denominator. Okay, that one, this one is the one that changed by 1 unit. So we say that for a unit increase in x, y will increase by how much? Increase by 5 units. So now I put the units, okay? For 1 unit. Before I don't put the unit, I just want to focus on the numbers. But now we just say the unit of x and y is simply in terms of units, whatever the unit is, okay? So for unit increase in x, y will increase by 5 units. Or like I said, macam tadi, the increase in y for a unit increase in x is now what? 5 units. Okay? Okay. So here is another way of saying it. Okay, now, if the x is decreasing, you got negative, decrease. Okay, what about y? Y will also have negative sign, decreases. So now, I want you to describe in terms of decreases.
Decreases, what is the changing, the x or y?
So here, is it x decreases or is it y decreases? Or
Both decreases.
both. Okay,
Both.
both decrease because m is positive. That means both will decrease. Okay, negative over negative will be positive. Positive over positive is positive. So here you have, if you have a decrease, that means both will decrease. Okay, is that clear?
Okay.
So if it is a decrease in x, then what happened to the y?
Decrease.
So
Also decrease.
can you put it in a proper sentence? Okay, somebody try.
For a unit decrease in X, Y decrease by 5 units.
So for a unit decrease in X, Y decreases by 5 units. Or for a unit decrease in X, the decrease in Y is 5 units. Okay, so as we said earlier, for positive slope, they both move the same direction. So we can either put increase and decrease, or you can put a decrease and decrease. Okay, so make sure we know both, because that comes from the sign. Okay, now let's move on. We try the negative slope. The one that you have was negative y(x) equal to negative 0.3 lah, betul tak 3? 0.3 ya 3?
Yes.
Yes.
Okay, 0.3, negative 0.3. And that is, of course, delta y over delta x. Now, to get the idea per unit, 0.3 is what? Negative 0.3 is 0, negative 0.3 over 1. Any number is actually that number divided by 1. Okay, so here you've got per unit change in x. Now, if x has a positive change, in other words, x increases. Now, what about y?
Decrease.
Y will decrease.
Increase.
Okay, y will decrease. So here, when you describe it, you must describe it according to the sign. Okay, so here we can say for a unit increase in x, what about y? Y will decrease. Okay, y decreases by how much? By 0.3 units. So now you don't have to say by negative 0.3. Okay, because the decrease already take care of the sign. So the y decreases by 0.3 units. So here they move opposite direction. Okay, y increase, x increase, y decrease. Okay, any question about this? All right,
No.
now we go the other way around. Now let us suppose the x move negative direction. In other words, x will decrease. Now what about y?
Increase.
Y increase. Okay, y will increase. So I want you to describe the slope negative 0.3 in terms of a unit decrease in x.
For a unit decrease in X, Y increase by 0.3 unit.
Okay, so for a unit decrease in x, y increase by 0.3 units. So negative slope means they move different direction. Okay, so you have to understand both. The x can be increased by 1 unit, or the x can decrease by 1 unit. But normally, okay, normally when you describe common application, we normally put the increase in x. The x increased by 1 unit, and then you see whatever happened to y. But the relationship between the sign, the change is important. If x is negative change, then if the slope is negative, that means y will be increasing. Okay, so that is the example. We go for the other example. What was the other example? Finish up the example. Second example tadi M berapa? Negative apa M?
Negative 2.86.
Negative 2.86. So again here, that is delta y over delta x. Okay, by now I think kacang lah. Okay, I want you everybody to write down this one. Okay, you don't have to say it to me, write it down. I hope everybody will got it right. So you start, number 1. Unit increase in x. Okay, x increase. So if x increase by 1 unit, what about y? Y will decrease. Okay, buat yang tu dulu. Everybody right? Okay. Jangan tengok. Okay. Now, after that, you do it the other way around. Okay. The other possibility is you have a negative change for the x. That means x will decrease. Now, when x decrease, that means y will increase. Okay. Do that one. Okay. Semua boleh buat, eh? Alright. So what we have been doing is, this is in 1.3. Okay, we were discussing now is 1.3. So we already interpret. Okay, we already describe the slope and already describe the intercept. So I will look at application because it's still fresh in our head. So we are going to relate. Okay, we're going to relate the concept of the slope here to one application. You look at application 1.3, example number 2. So go to example number 2. Example number 2 in 1.3, debt depreciation. Okay, I want you to read that example because in this example, we are going to apply, all right, whatever we already learned so far. Okay, the slope, the intercept, the general form, and then the slope intercept form, and then how you draw the graph. Okay, so everything is in this example. So go to example number 1.3. Okay, everybody, please read that example. Read for a few minutes, and then we will go through that thing. Because that example is actually very, very basic and very important. Okay, now, if you look at that example, what is this about? So when you look at application, okay, application example, you have to relate back to the concept, all right? You have to relate back to the concept. So this concept here is about linear function, okay? And you know linear function is either y equal to mx plus b, or you have ax plus by equal to c, okay? I ask you to read the general form and the thing. And then, of course, you need to find the slope, and then the intercept, the y-intercept, and then the x-intercept. All right? Now, these are the things that we normally do with a linear function. And of course, you draw the graph. Okay? You draw the graph. Now, when you look at this application, or any application, first thing that we need to look at is you are going to identify the variables. What is y and what is x? That means from what you have here, y equal to mx plus c, then you look at the application question, then you know, or you have to identify what is the y, what is the x. Okay? So if you look at this example is about depreciation. So what is y and what is x? It's already being written there. Okay, what is Y, what is X? Okay, first, before you know what is Y and is X, this problem is about what? This problem is about a business property or an asset. Okay, it's a property, asset, a building, or whatever it is, and it's purchased by with under a certain price. Okay, and then it depreciated over 10. It's depreciated over time. Okay, it's depreciation over time. So property depreciated. Okay, depreciated over time. So that is the essence of the problem. So the property depreciated over time. Okay. So if you want to look at this problem, it's about what? It's not about the property. It's about the value of the property, which depreciated over time. Okay. So from here, you can see the value of the property depend on what? The value of the property depend on the time. So the value V is equal to what? Is equal to some function of time. Okay? And the value you relate back to our concept, that would be Y as a function of X. Okay? So what do? We let the value of the property, okay, of the asset in the unit. What is the unit? Dollars. E equal to Y. So when you look at application, you have to be aware of the units. Okay, so important thing here, the units. And then what is the X? X is the time. Now, what is the unit for the time that is given here? The unit for the time. Is it months? Is it years? Is it day? Or is it hours? Or is it minutes? Seconds?
Yes.
Years.
Year. Time in years. So we call it X. Okay. So you got Y as a function of X. Y is the value of the asset. X now is the time in years. Okay. So you have the value, a function of time. Y as a function of X. Y is the value of the asset. X is the time in years. So it is given already, it's given already in the, or some information is given, and then you are given by the general form of the function. So given the general form of the function, what I want you to do, okay, given the general form, I want you to do number one. I want you to rewrite in the slope intercept form, y equal to mx plus b. Okay, do it now. We have a few more minutes. You write that general form, okay, right, in terms of y as a function of x. Because in functional form, y is the value, okay, and that value depend on the time. So y function of x. Okay, can you write down the function? Anybody who get it first, let me know. Do the work, okay? Do the step. Don't just jump, get the answer, okay? Do the step. It's okay. Do the more step is fine than less step. Do it one by one. You bring to the left, you bring to the right. Whatever happen, become negative or positive, or become divide or multiply. So show everything. Okay, what do you get? You'll get cepat. Okay. Now you bring the 4 to the other side. You divide, okay, becomes division. So you divide everything by 4. Okay, what is it equal to? You divide 4 by each of the terms on the right. Anybody get what is the slope?
Negative 1024x.
Negative
Negative
1000
1.
20 and 24x.
1024.
Yes.
Okay, negative
24.
1024x plus. Okay, 491520. You divide by 4. 122 kan?
122880.
22
880.
880.
Yes,
So if
sir.
you have this form,
Yes.
you have that
1, 2,
form,
8, 0.
it give you a better idea, okay, of the line, because you have the value in terms of time. All right, and we are going to do a few recognition or a few description here or a few interpretation. Number 1, you draw the graph. Okay, you draw the graph. All right, number 1, draw the graph. Okay, now you draw the graph, you find the intercept. Get the Y-intercept, get the X-intercept, draw the graph. Of course, if you look at the book, the graph is already there. That will be guideline, okay, to ensure that we got it right. I would like everybody to work this out, okay? Even though the answers are given in the book, you work on your own and see whether you get the correct answer or not, as per the book. So what you want to do now is get the Y-intercept, and then get the X-intercept, draw the line, okay? Okay, what is the Y-intercept? Y-intercept, senang eh? Okay, what is the Y-intercept?
12280.
Inilah dia Y-intercept. Okay, the B is the Y-intercept. So that one, you just say Y-intercept is when X equal to 0. So Y is equal to 1228880. Straightforward. The X-intercept, that one is not so straightforward. You have to set Y equal to 0, and then you got to find what is the value of X. So everybody got it? What do you get?
120.
Everybody got 120? Okay. So what you do here to get the intercept, Y-intercept, that means X equal to 0, and then you get the Y. Okay, straightforward from there. And then what is the value? The value is 0, 1, 2, 2, 8, 8, 0. So that is the point. Okay, so that's the point. Now the X-intercept, Y equal to 0. So what do you get? You get 0 equal to berapa tadi? Cek balik berapa? Saya ni panjang ni. So I cannot remember the numbers, too big. So what you do on your own. Get Y equal to 0, then you get apa benda. Okay, what do you get? Then X will be equal to whatever. So X is equal to 120.
0.
Okay, show the work. Okay, show me the work. Don't just show me the answer. Now, another thing in mathematics, the answer is as important as the step. Okay, if you give me the right answer without the steps, how you get the answer? The answer doesn't come from the moon. Okay, so the show of the answer, okay, the steps, the working is very important. So I will always like you show me extra work. That's fine. Okay. rather than you give me jumping and then get the answer. So I do not know how you get the answer. I want to know how you get the answer. And sometimes due to some error, you make a mistake, you get the wrong answer, but the steps are correct. So I prefer that. Then you give me the correct answer without the steps. Okay, all right. So the steps, the working is very important. So please bear that. So now you got the X-intercept, that is 120, 0. So given the values of the Y here, the values of the X, you can have an idea of the scale, okay? Scale of the scale and interval for the X and Y, all right? Now, what is a good scale for the X? 120. What is a good scale? The book used 20. Okay, now, if you give me another scale, berapa you nak guna? Sometimes, scale interval pun saya pun pening. Interval. What interval do you want to use? I think the scale is when you draw the graph, how many cm for each of the value. The interval is what is the distance between each value of the X and Y. Okay, for the X, other than 20, what do you suggest?
30 or 40.
Huh?
30 or 40.
Okay, one is 30. Give me another one. 130, the other 40. Okay, two. Give me one more.
60.
60. Lagi satu yang senang. Selalu benda kita pakai.
10.
10 tu besarnya. Kalau 10, you have to draw a big graph. $50 lah. Tak ada orang panggil 50. 50,
Oh, 50.
Sometimes the easier scale, 10, 50, 100. Okay, a multiple of 0, 0. All right. The book use 20, or you can use 40, or you can use 30. All right. But if I were doing this one, I think I will use 20, 50. Yeah. Okay. But if you use 40, okay lah. Don't use 100. 100 is 100. You'll get a very, very small scale. All right. Now for the Y, you have a higher value. So if you look at the book uses 20,000. Now, give me another scale other than 20.
$50,000.
40. Okay, you can do 40. Okay, one more.
50,000.
50,000. So I like 50,000. Okay, 50,000, 40,000. Okay, 30,000. Okay, all right. So you do the graph, or if the graph is already there, so you just draw roughly. You don't have to draw very nice. Just have the scale with another scale from the book. That is, so you either use 50,000 or 40,000. Then that's it. All right. So I think, our time is already 1:22. So I think I have to stop here because some of you may have a class at 11:30. So I'm going to stop here. I will continue. So what I would like you to do, you go home, finish up this example. I would like you to draw. Okay, we already have a step of drawing. I want you to look at the slope. All right, what is the slope? What is the intercept? B. And what is the X intercept? Okay, we already, of course, we know. Now, I want you to interpret. Okay, interpret means you have to describe. Okay, describe more detail. Right, in terms of the units, and then in terms of the direction of the movement. All right, either it's increase or decrease or whatever. Okay, so I want you to interpret the slope. I want you to interpret the B, the Y-intercept. And then I want you to interpret the X-intercept. So not just getting the value, but looking at the meaning of the value. So in application, we're going to look at the meaning, okay? And then we should understand what is that thing. So I would like you to do this. And then on Wednesday, I will continue from it. All right? But get the idea first. Okay, now, I think that's it for today. So if anybody who is still without group, let me know, okay, in the WhatsApp group. And like I tell you earlier, please put your real name in this either WhatsApp or here, okay, or in this list name here. In the WhatsApp, yeah, I will let you know as we need it. For the Zoom, okay, for the Zoom, can you add in your section number? Okay, just put either 4, 5, or 6. You don't have to put section. Just put a dash, 4, 3, no, 4, 5, or 6. If there is not enough space, then you can skip the metric number. Just write your name, okay, like I stated earlier, and then your section. So that it's easy for me to map. Okay, this is a mapping to map your name to the name list. So it's a function, okay, one-to-one correspondence. So I want to make sure we got that. Okay, and here, please letak picture. Okay, I've been, online. You never know your student. You forgot the names. You don't know how they look like. All right, so at least, like now, Alia, dengan letak A, put your name, put your face. All right, macam Haziani, at least I know how you look like a little bit. All right, so this is for class purposes. All right, it's nothing more than that. It's just for class purposes. Now, when you have a class, a teacher and a student, you have to know. Okay, you have to know to each other. So that the knowledge, okay, the knowledge or the discussion or the thing that we discuss is based on mutual recognition. Okay, you recognize me, I recognize you, and of course that is very important. Okay, you know the teacher know the students. Of course, not that much, a little bit. All right. Okay, so that's why I need your picture here at least. Okay. All right. So I think I will see you again. Have a nice day. Have a nice week. I will see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Okay,
Thank you, sir.
waalaikumsalam.
Thank you,
Thank you,
sir. Have a nice
sir.
day.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you. I'll see you again.